Today we're doing section 2.5, and this is finding the zeros of polynomials, day 1. So to find our list of possible zeros, you're going to take your factors of your constant term, and you divide it by the factors of the leading coefficient. And if you don't know what I'm talking about versus the phrase of constant versus leading coefficient, your constant is the number without the variable, and your leading coefficient is the number in front of x with highest exponent. So we're just going to try one example of finding all the possible zeros, and then the second example we'll do is actually finding the exact zeros. So again, this list is just a list of possible zeros. Doesn't necessarily mean that all of them are zeros. So our constant term is -6. Our leading coefficient is 1. So our factors of a -6 would be a plus or minus 1, a plus or minus 2, plus or minus 3, and a plus or minus 6. So the reason we put plus or minuses on there is a positive 1 and a -6 gives me -6. Well, a -1 and a positive 6 gives me -6. So we need all variations. And for positive 1, again, I need a plus or minus 1 because 1 times 1 is 1, but -1 times -1 is also 1. And then we would go through and divide these. Now, when I divide them by 1, they're not going to really change at all. So my final list is plus or minus 1, plus or minus 2, plus or minus 3, and a plus or minus 6. So in the next problem, I'll show you what we're going to actually do once we have our list. We're going to go further. So here we have f of x equals x cubed plus 7x squared plus 11x minus 3. Again, if you tried grouping it, it's not factorable. Notice I didn't give you a 0 this time. So now we're removing that stuff from you, and you have to determine it on your own. So we're going to start by making our list of possible zeros. So my constant term is -3, leading coefficient's 1. So I'm going to plus or minus 1 and a plus or minus 3 over a plus or minus 1. So that means our final list is just plus or minus 1 and a plus or minus 3. So now we need to determine of these 4 possible zeros which one is a 0. So to do that, we can use the remainder theorem where we said I can plug it in, and the one that gives me 0 is a 0, or I could do synthetic. So I'll kind of do a mixture of both methods. So let's test 1. So if I were to test a 1, I'm going to do synthetic. And whatever you think is easier, synthetic might be easier, or plugging it in might be easier. So I'll drop the 1. 1 times 1 is 1. 7 plus 1 is 8 times. Get 8, 19, 19, and I can already tell that this is not going to be 0. So 1 is out. Now I'm going to try -1. So I have 1, 7, 11, -3. So 1, -1, 6, -6. I get 5 and a -5. So again, it's not going to be 0. So now let's test a 3. So I drop my 1, 3, we get 10 when I add, 30, and I could stop right there. I know 3 times 41 is not going to be a positive 3, so I will definitely get a remainder. So the last one we need to check is a -3. So drop the 1, -3. When I add, I get 4. Multiply, we get -12. Add, we get -1, and a positive 3. So now we found our one with no remainder. So that means -3 is a 0 of the function. So I'm going to switch the screen so that I can continue this problem. So just to kind of copy that back down, and my numbers were 1, 4, and a -1. So an answer of -3 means it came from an x plus 3, and I'm down to the second power. So x squared plus 4x minus 1. And this is not going to be factorable. Nothing's going to multiply to be -1 and add to be 4. So I have to do the quadratic formula for that second part. So a is 1, b is 4, c is -1. So I have -4 plus or minus b squared, which is 16, minus 4 times 1 times -1, all over 2 times a, which is 1, so 2 times 1 is 2. Underneath the radical, we'll get 16 plus 4, which is 20, which I know breaks down to be 2 root 5. So put that back in here. I have -4 plus or minus 2 root 5 all over 2. And I could just divide everything by 2. So I'll get -2 plus or minus root 5. So that represents 2 answers for x. And then our third answer is that initial 0 that we found, -3. So notice this isn't much different than yesterday's lesson. It's just I've now removed the fact that I'm not going to tell you one of the zeros. You have to obtain it on your own by finding the list. So we're going to do one more together. This one actually gives you another piece of information. So in the textbook, it has this picture next to the problem. So this is supposed to be a piece of the graph, if you were to look at this function in the calculator, and that is supposed to be touching right there. So based on this picture, I can determine that one of the zeros is possibly 2. It appears like it's crossing at 2, so I would test it with synthetic. So notice my list, I'm dealing with the 24. So my list would be plus or minus 1, 2, 3, 4, 6, 8, 12, and a 24. And when our list starts to become this large, we don't really want to sit there and test all these numbers. It takes a lot of time. So instead we use the calculator, and I can see that it's going to cross the function at 2. So I'm going to do synthetic at 2. So I have a 1, 0, -1, -8, and a 24. So I drop my 1, I multiply, we add, and I add, I get -2. Let's see, looks like I made a mistake somewhere. Oh, right here. It should be 1, 0. This should be -6, not -1. All right, so let me backtrack. So, and the reason I knew I made a mistake is you're not supposed to get a remainder. All right, so -6 plus 4 is -2. 2 times -2 is -4. This gives me -12. That gives me the -24. So there we go. So now I'm at x minus 2, and I have x cubed plus 2x squared minus 2x minus 12. Now I can make a new list, but again, we have the picture, and it appears that 2 is a double root. So remember we talked about the other day, if a function touches the graph, it doesn't cross through, it just touches the graph and turns back around, it's a double root. So that means the answer of 2 itself is what we call a double root. So 2 is going to work again for synthetic so that I can bump myself down to the second power. So I'm actually going to erase this so I have room. And we're going to do synthetic again with the answer of 2. So I'm just going to continue this on with this new set of numbers. So I'm going to drop my 1, we multiply, we add, multiply, add, and multiply. So I'm now at the point where I have x minus 2 squared. So that's coming from the fact that 2 is an answer 2 times. And now I'm at x squared plus 4x plus 6. and it's equal to 0. So we think about 1 multiplies to be 6 and adds to be 4, and that's nothing. So again, we're going to have to do quadratic. So I'm going to switch to the next screen so I have some more room. So I'm at x minus 2 squared, and it was x squared plus 4x plus 6. So we're going to go ahead and do quadratic. So I have negative 4 plus or minus b squared is going to be 16 minus 4 times 1 times 6 all over 2. Underneath the radical, we'll get 16 minus 24, which is negative 8, which breaks down to be 2i root 2. So then I put that back into the problem. I have negative 4 plus or minus 2i square root 2 all over 2. And that can reduce to be negative 2 plus or minus I root 2. And my other two answers are positive 2 times. And no, you don't need to write it out 2 times. It's implied to be a double root. So that's all for today. We'll do some of these tomorrow.